So we will be talking today about console development, and most of what we're going to be talking about is applicable for mobile as well to some extent. So we're going to be presenting our best practices that and tools that we've been developing at Behaviour for the last few years. So it's a solution for us, maybe not for you. So these are our thoughts about a few things for developing on consoles with Unity. So my name is Jean-Francois Mercure-Burroughs. I'm programming director at Behaviour.
And my name is Vincent Achim. I'm a technical director at Behaviour.
Oops, sorry.
Yeah, I'll do it.
So bear with us. It's 8:30 Montreal time, and it's been a long day for you guys and us as well. So it's going to be a fun ride. So we're getting hired at Behaviour for our capacity to do cross-platform development. The publishers are coming to us to maximize the availability and the amount of platform on which our product will be sold. So usually we get a couple of platforms to support, PS3, Wii U. And since the market is evolving at this point, we usually get a phone call at some point during production, 6 months into the project for a 10-month project. And eventually, they're going to say, oh, might as well put in a Vita SKU into the build. All right. Or they just announced a PS4, let's add it as well. And all this needs to happen within a single team. So we have one large team and lots of platform to support. Limited time, so basically we have a single team to build it up. We have to, and with a similar launch date, other than marketing. So for instance, Nintendo will ask more time because you need to get cartridges that takes a bit more time than a DVD to be produced. So, but it's all within the same time period. So our job is basically to make it possible to ship all those SKUs on time, on budget, with a single large team or larger team. So cross-platform development requires changes to your structure in your team and as well as the way you're working. How can you do it? So we've developed 3 different engines at Behaviour over the past years, supporting multiple platforms. Or you can go for a more commercial engine like Unity. And the reason why we're switching over to Unity at Behaviour is because we've been proactive along the years to develop our own tech so that we're not relying on any third party. But to some extent, you're always working on tooling is cool, but you're always missing this step. So we're always looking to improve our productivity, and that's exactly what Unity is bringing us. It's easy to add tools, customize to our needs, and fit very with the way we're working. But there are a few issues that we'll be talking about today. We're going to be discussing how we solve these problems. There are a way of addressing those. How to deal with large team and increase productivity using Unity as well. How do you deal with different system limitation, going from a portable like a Vita or a Wii to a PS4 and the Xbox One as well. And also, why you should be investing in a continuous build integration. So making sure that everything flows. Building cross-platform product requires somewhat of a larger team, not a tremendous amount of people, but a bit more. And it's our job to prevent the team to go into the you can't work syndrome. Like, oh, that guy has the file checked out, the scene is locked, can't work. And then you've got all these guys sitting around that can't work. So how do you solve that issue? Because environments, breakables, AI, camera, all folds into a single scene. Oops. A lot of people requiring to work on that file. So that works fine for a small team with a content integrator. There's ways to work around that. One of them could be to use prefabs. You're only delaying the problem because eventually somebody else will have the prefab checked out. Or you can go up with a prefab of prefab and build your own tool. Might work as well. That might work as well. Or there's the other way, the other approach is to build your own file system, which is also a bad idea because it doesn't scale with any plugin that you would buy on the asset store. And we love everything that you guys are producing, so which means that we want to be able to use it. It requires to reverse engineer any changes that Unity does between versions. And the one thing you don't want to move away with Unity is the WYSIWYG. What you see is what you get. So going with that system is still yet a bad thing. Same graphic, but the concept changed. So what we've done is that we're splitting the work between basically each of those are becoming our scenes that are being that are now called layers. And we're building at runtime, we're using those to create an actual level. So we're splitting the work between groups. Level designer got their own layers, artists got their own layers. For example, level designer will have the breakable, the AI, any waypoint system, and then two level designer can work together on the same area without worrying about, oh, that guy has it checked out. All right, so no file system, you're keeping the existing scenes. And all this is based on a folder structure. Basically, each Unity scene that you drop into a single folder gets linked to a level. So your folder is your level now. So programmers don't really need to really understand how the artist or content developer are building their level. All they need to know is the name of the folder to load. So, as I was saying, a level is a combination of scenes. The layers are built to be working on top of each other, so they represent the same area in the game. So, and all that information, metadata, which works fine inside the editor, needs to be wrapped up somehow so that at runtime you know that, oh, if I want to load level X, it's layer or scenes A, B, C, D. So it's all wrapped up into some piece of code that we've centralized between our projects. So programmers don't need to care, and content developer can go crazy in their file structure as long as they keep it to a single scene. So if there are 25 layers, there might be a problem. Let's focus about that later on. But we don't need to care, or we need to care about it, but not a big deal at this point. The other system that provides is the ability to create a bootstrap. Right now, if you need to establish like what is scene 0, which is the one that you'll be loading. So we've got a system in place to basically say, all right, that's the scene that I want to start. So you can basically create a main to your game. So we've solved the problem where an artist is fighting over a level designer for a single scene. But how do you solve the problem when you've got two artists? So you segment the area in your game. It will require a bit more work because of nav mesh, lighting, stuff like that. But if you can pull it out, that way you can have multiple sections of the game, either by using bundles or other elements. That way you can segment the world and having everybody work on their area without having to struggle within the team. So that's our tool, or part of it, the visual part of it. So as you can see, we've got different layers. It's a screenshot from a prototype we're building. So we've got the environment layer. The level 1 is basically level design layer. We've got sound effects, VFX. With these, you can actually load extra scenes within your scene because it's okay to have reference. So that's the way we're doing it. And if you guys have tried something like that, there's only a single scene at once inside Unity, even in editor mode. So what we're doing is that we're loading the extra scenes as additional layers and tagging those as part of a layer. That way in the hierarchy, they're all grouped together. and you could actually hide them or not. That way you can have, let's say you've got, there's a fall, and then you've got those VFX and sound effects that are placed all in different layers, and then if somebody moves the environment around, they can actually go in, click Make Editable into a scene, and just switch over. So by doing this, what you'll be doing is unloading everything, reloading all the previous loaded layer, but now you're inside the VFX layer, for instance, and then you've got the ability to move it. And that can also be, like, all that is connected to your source control that comes in with Unity 4.2. So if you're using per4 subversion or thing like that, so that way you know that if you're switching over to a new scene, and somebody else has the file checked out, you're not screwing over his work or your own. So I was saying that, let's say I've got area A, and then I'm building something that will stream. And there's always a problem where you've got two sections of your game that are next to each other. And what you want to do is to be able to see them in the editor to make sure that at least the level is the same height, right? You don't want to create a gap. So you can load individual scenes that way and turn them visible or not. And these things are kept actually inside your user preference so that if you're moving and if you're always working on the same area, when you come back in the morning after a day, you know that you can easily pick them up and then reload them to go on and off quickly. So that allows you to add many layers. So the environment artist can actually just load in for his section, the environment, and then load adjacent or the proximity layers that are there and do his own, continue and making sure that everything's fine. So what's missing in there that is on our list is the ability to actually to merge layers. Because I said previously that content developer can go crazy. So if you've got 25 layers of SFX because for some reason everybody started doing SFX, then you probably want to bundle them together into a single scene. So that's missing. It's in our pipeline. And the ability to copy layers or to move objects from one layer to another. So that is something as well that our artists have been requesting for the last few weeks and months. So with that system, you're allowing multiple people to actually work in the game and without actually working with Unity, not against it. So we haven't created any new file structure. Everything is actually inside the parameter of Unity, and you're still WYSIWYG.
Okay. So we all do game with passion, so we all want to have like the maximum asset content for each platform. But as Jeff said, we are working with platforms that are like really broad, so and doesn't have the same memory capacity, doesn't have the same GPU, the same CPU, and everything. So at some point you will find yourself with the yes, but it doesn't fit on console X. And this always happens near like when you are trying to ship your milestone because you want everyone is adding his last minute check-in. And so you really want to be at that point ready to make some change live at your environment. So what we decided to do at Behaviour, it's a simple. It's only to select per platform basis what to load. That way you can easily downscale, replace at build time and at runtime, at the end it will be at runtime, the asset inside. So what the system looks like, it's kind of the same system layer that they were previously, but this one is for the build, what gets inside the build. So we select a layer and say, for instance, on this one it's on Windows, but let's say on the Wii you wouldn't like include the VFX or this super special VFX, or you wouldn't include the things that are moving on the background that are only there like to create movement because the frame rate is not enough or something like this. This really works well when you like just remove parts. But at some point, you will want to just replace an asset. And at that time, you don't want to duplicate the asset and have to mess around with the things. You don't want to be forced to sync every change because the bug fix will come at the last minute, and you don't want your artists or your designers to just go into each scene and replace and move them. So what we do for it, it's creating a simple mono behavior. Instantiating an object inside at runtime inside a game is a common thing. It's only a spawner you call instantiate it, instantiate your game object. The thing that is the beauty of Unity is that everything can be also done inside the editor. You only have to add the execute and edit mode. So that way you are able to instantiate in the editor. For sure, there are things that you need to consider when you are doing it because now it's part of your scene. So you have to be sure that you add the flag of don't save and that not both of the objects get inside your final build that you can switch. But with it, you are able to change only like we use a simple platform window where we say, okay, we want to switch this config, and then you load inside the editor what is there and what you see. I don't know for you, but for me, when I'm playing a game, the thing that is really annoying is the loading screen. So it's not much different when you are creating a game. In fact, you don't want to lower your loading screen. But at the same time, you want to test every chain on every platform. And unfortunately, on Unity, when you switch from platform to platform, it takes time because it's rebuild a lot of assets and a lot of things. And so you want to be able to test your flow without, in fact, actually going inside without actually switching targets. And this is possible. In fact, it's easy. You only get the scriptable object where you add some defines. We are using, for instance, in this one, we have the default console, which has no extra defines, but like the Wii one would have like a behavior or something that you set up. And with a space, like a simple window, which only said what should be on the screen. The thing that you have to know is that Unity is built over Mono. And in Mono, you can modify a file called smcs.rsp, which is where you can add global defines inside the build, and it will be a global define everywhere. So, and there's something for Java, it's us.rsp or something like this. The documentation is clear on Unity website, but it's something that not more people knows of. So let's see a simple script of how this will work. So it's really simple. It's in fact, and it can be for sure made more complex, but at the basis it's like you get what changed between different platforms because you don't want to recompile the file for nothing. You just want to recompile the one that has the platform dependent stuff. So you check for if there are any difference in the defines, and then you dump the stuff inside the smcs.rsp with a semicolon inside it. And then you just parse your solution for the CS. In fact, in this one, we're just parsing for the CS. And the only thing you have to do is to find, oh, is my C# script having this defined inside it? Yes, okay, I will just like re-import it, and it forces to recompile. So let's look at what it's looking, in fact. So we have a short video. So here we again have this behavior which is only defined on the default on the Wii platform. We are on the Wii, so this is a normal cube. It's moving like a normal cube. This is the proxying thing. So we are able to define what gets inside which build, and we don't show it, but the character in this video, but the character also has a mesh LOD associated with. We have a rotate mesh without a behavior it does nothing, and else it will like do a simple rotate. So as we're on the Wii platform, we click play, and nothing happens. The cube doesn't rotate. But you only just change the platform, and now it changes the asset. It recompiled the rotate.cs, and then you click play. And now you have your cube inside the editor that is there, and it's really like it's super fast to test most of the flow. Of course, at some point you will want to get on the real platform because there are things that are only on that platform. But you will be able to do a lot of things there without entering like switching platform and losing time doing it. This is great. This works fine. It's helped you to improve. But at some point, you will want, whoops, oh, sorry, start back. So at some point, you will want to add continuous and automated integration. continuous integrated automation is super simple. It's just like every time someone checks in, a build gets started, and you look at if the build will fail, you collect your stat on the, and then you are able to test it on the device. We are using Jenkins, but there are a lot of, and it's really, but there are a lot of integration or continuous integration out there. You really want to invest in it because it will save you a lot of time. It's something to see that like a build fail on a specific platform and find out why it fails if it doesn't, but if the builds compile and when you launch it, it's just like died there. It's a bit more difficult to say, oh yeah, it's because this asset grown up of that much and that. So inside the integration, it's kind of easy to add to Unity the statistics and see, oh yeah, at that change list, oh, there's a big spike there. Oh yeah, the artist forgot to put the texture, he put the wrong texture in the wrong directory or something like this. So really, you want to invest in it. And other things that continuous integration will help you with is it's easy also to see when to sync. You don't want your artist or your designer to sync a build that is broken. So basically, you would see an icon on the tray saying, oh yeah, currently the build is broken, don't sync it. And the last thing that we do is we use something that we call the submit assistance, which checks the build state and don't allow someone to check in over a build break or over a build break. So that way you are able to fix the problem that are in your build without adding more problem to the build and like trying to solve 2 or 3 problems at the same time. Okay, this is great, but how it works with Unity? In fact, in Unity, there's a batch mode. And this is the only thing that you have to know. It's that you can call the batch mode with like, it's only calling Unity with adding batch mode on it and calling your methods that you need. And then it's super simple to do it, but like it will save you a lot of times. So that's almost it. So when you do console development, the important thing is planning for your maximum efficiency of the team, because you are working, most of the project are working with bigger teams. So if you can improve just a bit, then it will save. We were doing calculation, and if everyone in a team of 20 save like 10 minutes a day because like you are customizing your build, you are adapting it to your needs, then it's more than a month of programming. So really it will help out, but because you will have done it on the first project, when you will do it for the next, you will have it. So really customize, because also as we see, it's super easy to customize to fit your needs. Set up continuous automated integration. You will like love it when it will be in place. It's not difficult. Of course, you have to use version control, but yeah, you should also. Yeah, and so test every change for build breaks on all platforms. Most people will develop on PCs and don't like to test on platform. It's like your duty to like remember them to, okay, yeah, test it on platform, test it. And if you have like tools that are able you to go fast switching, then there's more probability that they will be testing it and that less bug will enter into your build. And yeah, this will make your team happy. And that's it. Thank you. Do you have any question? I know we didn't like go into the details of the thing, but yeah, the real thing is like customize to your need, put it, because Unity is a real, and the editor mode is something that is really fun.
Yeah, a couple questions about the continuous integration testing. Did I misunderstand, or do you guys actually have a way to run it on devices and test as part of the build process?
We have some. Well, we are working on something to like really optimize it. I don't know if
on some mobile device, it's pretty hard.
Yeah.
Of course, you need to have your game ready for that to be able to send back metrics. either through internal website or you need to have your game needs to be made for it. So usually what we try to do at least is just make sure that it loads.
Yeah, because most of the problems is like your game won't load. Having some bugs in it, it's something, but yeah, we just ensure, and basically it can be as simple as, but I'm not sure on mobile it would work, but on console you are able like to write a file to a disk and then you check if it's there, and it's
Okay.
kind of simple.
Is that just part of your build script, or are you using like any specific tool?
Yeah, for most of that system, we're using the build pipeline from within Unity.
Yeah, which is available only on the Pro version, I guess, but
All right. Thanks.
we are using it.
Thank
Okay.
you.
Thank you.